Hey robot makers, hope you're having a good day so far. So do you want to know how to monitor all of your Raspberry Pis using Telegraph, Influx and Grafana? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. So let me show you today what we're aiming for, and yeah, you can take a look on there. This is the kind of thing we're going to be building out in today's show. How cool is that? So these are just a couple of the Raspberry Pis. I've not installed it on all of them yet, but you can see there we've got like the disk space, how much system load they've got, the uptime. We had a power cut yesterday, just before yesterday, and it actually took out one of my Raspberry Pis, and I've been meaning to do this kind of monitoring thing for a while, mostly for disk space because that's not easy to see without logging onto each of them, and also just to see the kind of load. Like I can see there, my Dev1 machine has got 11 containers currently running on it, which is quite a lot compared to the rest of them. You can also see there the kind of network traffic that's sort of undergoing. So this is what we're going to be building out today. It's much easier than you would think, and I've done a lot of the homework for you. So if you want to play along, you can go to kezrobots.com, and you can go to the blog and you can find the article which is all about Telegraph. You can see I've been busy creating lots of other how to do this on Pi type tutorials as well, and yes, this is the one that today's show's about, which is Telegraph. So all the instructions are on there if you want to play along and set up your own. So let's get over to it, shall we? So yes, it's all about Telegraph. You might not have heard of this before. It's a piece of software. It's by the same company that does Influx database, Influx. So we're going to look at why would you want to monitor your servers. Let's go through that. We're going to look at what Telegraph is, take a look at that. We'll look at InfluxDB. We have used this previously on, I think, the weather station video. We're going to look at Grafana, which we have looked at previously as well, but we'll dive into that a bit better. I've also got some sort of cheat codes for that to make it even easier to use. We'll certainly have a demo. We'll build out a dashboard, and then after that we'll have a bit of a live stream Q&A and anything left in the mailbox after last week's show. Okay, let's get to it then. So why would you want to monitor anything on your network? So you can proactively detect issues. So for example, if one of your Raspberry Pis, say the little SD card, if people are still using these, is getting a little bit full, then you'll be able to see that on one of the charts very easily. We can even have an alert get sent out to you should one of these breach some threshold. Performance optimization, so we're looking at these key metrics, these KPIs, such as the memory consumption, the CPU usage, and so on. We might realize that there's some bottlenecks and we can spread that load out onto some different Raspberry Pis if they're doing some kind of work for us, which I've got behind me a bunch just there of Raspberry Pis, and just off camera to the just behind me to the left, to your right, is another bunch of Raspberry Pis which are all running kezrobots.com. You can also potentially have security threat detection. This is something I do for my day job. We can look at how you could include some information, some log files from your network to detect unauthorized access or malicious activity and so on. And also capacity planning. So this is the main reason I'll be looking for this. Is everything running as it should? Do I need to start moving things, deleting files and so on? So we'll have a look at that as well. So this is the kind of workflow. These three main components are going to work together to build the dashboard today. So Telegraph is going to capture the metrics from our Raspberry Pis. You can also use this to aggregate data together. And what we mean by that is, say you don't want to count everything, you just want like the mean or the average or the maximum or minimum values. That aggregation can be done in the Telegraph agent. It can also process some data, so maybe you want to add like a location or some extra information to the capture, you can do that there. And it will also export the data onto Influx, which is the next component. So Influx is a time series based database. So traditional databases just record things in tables, and you might have several tables related together. Well, Influx is a time based database. So the idea is it will ingest things like log files that are time based, sequenced in time, and we can slice that time very, very quickly just to look at what was the metrics at this point in time, or for the last 20 minutes, or for the past 2 years. It can help us do that kind of slice and dice very, very quickly. And then finally we've got Grafana. So Grafana is the presentation layer of this this stack. It's going to present the data from all these data sources such as InfluxDB and Telegraph. So I'm going to build out all those in today's show. So let's have a look at Grafana. So Grafana is a free and open source visualization and monitoring tool. exactly what we're after, really. It's going to allow us to create and share dashboards and alerts, which is quite cool, as well as graph the various different data sources such as databases, web services and cloud services. And it can also enable us to look at system performance, track business metrics if you want to do that kind of thing, and gain insights into that data. So the insights we're looking for is, is there any of our Raspberry Pis that are offline, for example? They haven't checked in for a while, or is there any that are maxing out on any of their memory, CPU or disk space? So where does this all fit in? So Grafana itself doesn't store any data, it simply just presents data from a database. So connects to almost any data source known to mankind. It's very, very flexible, displays time-based data, and we can rapidly slice that data using the time-based tools, which we'll have a look on the dashboard. And you can build these visualizations from a user interface. You don't need to know any kind of query language. You can simply just click and you will get the queries built up using a little user interface, and then we can manage the access to the dashboards as well. So I built a weather dashboard not so long ago using the weather station that's just outside the robot lab, and that can capture all the data and present it in these nice little charts and so on. Okay, so let's see. Influx. So this is the time series database. So this is an open source database system, efficiently stores time series data, means we can quickly retrieve that based on a time period. So we can give it a time window and it'll give us the data at that time window. It uses the Flux query language. If you want to get into that in more depth, you can do, but you can just use the interface tools in Grafana to get around all that. And for ease of use, there's about 3 different versions now of Influx. There is the version 1, version 2 and version 3. Version 2 and 3 have got a user interface of their own, but they do require authentication and all the complexity that comes with that. So version 1.8 and lower, they simply allow you to throw your data in there and then just retrieve it without any kind of complex tokens or user accounts. So if you want to do what I'm doing today, you can simply just use this one. It's not the most secure solution, but I'm just recording how much disk space I've got. Okay, and then we've got Telegraph. So Telegraph is a server agent. It's a piece of software that's going to run on our Raspberry Pis or our Macs or Windows or whatever we have, and it's going to collect some metrics for that. So it can collect sensor information, system information. There is so many plugins available out there for Telegraph that they've just made this the go-to place for this. Works hand in hand with Influx. It's created by them, and they have 4 different types of plugin. So these input plugins which collect metrics from your source system. There's the output plugins which deliver the collected metrics. You've got the aggregators, and they can transform metrics using mean, min-max, etc., that kind of aggregation functions. And you can also process, such as enhance, add tags and things like that, any missing data. So we're simply just going to use the input and output ones today. We're just going to gather some data and send it on to Influx. So this is what I'm shooting for. So I've got my main 4 Raspberry Pis there. They're all Raspberry Pi 5s. They have a 1 terabyte NVMe drive each. And they're running kevsrobots.com, clusteredpi.com, and a few other services that they use, like the random fact of the day or the courses app. When you go to the courses page, that you're actually running on an app there, that's hosted by those 4 things there. So we've got the InfluxDB, that's going to store the time series database. So that's actually running on a Raspberry Pi 400, just to my left there. And then we've got on the top there the dashboards and alerts, and that's also running on that same Raspberry Pi 400. Now these are all running in Docker. Docker is a containerization software. We'll have a look at what Docker is all about in a second. So if you like this video, you want to make me make more videos like this, then hit that like button, drop me a comment, let me know how many Raspberry Pis you have and of what type. I'm very curious to know just how many you've got. I've got an unholy number of Raspberry Pis, mostly ones I purchased myself, I hasten to add, over the past couple of years, all the way from the original Pi and up. So let me know in the comments how many Raspberry Pis you have. And I do go live every single Sunday, so 7 o'clock, we're in Greenwich Mean Time now, we're in a winter time. So yes, you can catch me live and we can hang out and have a chat after the show as well. Okay, let's get over to Docker, containerization software. Not sure that's how you spell containerize, but hey. So Docker is a platform for developing, shipping and running applications. The whole shipping metaphor, they've gone like way overboard with this. So Docker enables you to separate your applications from your infrastructure so you can develop software quickly. Now, this really hit home to me when I first came across Docker. I was working for, I think it was like British Telecom or something, working for the Department for Work and Pensions account, I believe, and we had some software that the team were writing. It was like an in-house software package, and all the developers had their own install of this package, and they all had different versions of drivers and things. So when it came to testing, it would work on one guy's, but then not the other guys and other girls' machines, because they all had different development environments, and the shipping environment as well was different. So Docker enables you to really standardize how everything fits together. And it runs things in what they call containers, hence the shipping container metaphor there. So that means we can manage our infrastructure in the same way you manage your applications. I really like the idea of that. So for example, when that Raspberry Pi behind me died, and I think it died, we had a power cut. It was just happened to be doing a software update at that amount of time, and the NVMe drive, I think, got corrupt. So it just simply wouldn't boot up. It would just sort of sit there not doing anything. So I flattened that, I reinstalled the Raspberry Pi OS, and I downloaded my package, which I'll talk about very shortly, of all the different Docker containers, and I basically just brought them all up one after the other, and it was back up and running again in literally minutes. So I really like this. I've really bought into Docker. And it's free, of course, as well. So by taking advantage of Docker's methodology for shipping, testing, and deploying code quickly, you can significantly reduce your delay writing code and running it in production. So here's some of the differences between your traditional virtual machine infrastructure versus containerized applications. So you start out with the infrastructure at the bottom. You've got the same kind of Raspberry Pi hardware. You might have a Raspberry Pi 3 like this, for example. You've got your host OS on the containerized ones, whereas on the right hand side we've got the hypervisor, which is kind of even lower level than the operating system. And then on top of that, if you're running virtual machines, then you've got each virtual machine instance is emulating the entire hardware, the guest operating system, and then running the applications on all that stack. So it's really hungry for resources. On the left hand side we've got the containerized applications, so they just run in Docker, the Docker environment, and you can run all the applications side by side. So you don't have to emulate all the hardware and the guest operating system. You just run the code. It's really nice. So you can see there, containers are an abstraction at the application layer that packages code and dependencies together. The dependencies is the key there. Multiple containers can run on the same machine, and they share the same operating system kernel and all the other with all the other containers. So each is running in their own isolated processes and user space. Containers take up less space than virtual machines because you don't have to have the entire operating system emulated on each one. And they're typically in about tens of megabytes in size. They're very lightweight, and you can handle therefore more applications requiring fewer virtual machines and operating systems. It's much more lightweight. Virtual machines, on the other hand, they're an abstraction of physical hardware, turning one server into many servers, and this hypervisor allows you to run different operating systems potentially, all on the same hardware. And each VM includes a full version of the operating system, the application, the necessary binaries, and they take up typically tens of gigabytes. So VMs are also very slow to boot up. So you can see here, containers are kind of winning in that, which is the best tech to use for this kind of stuff. So a container is a sandbox process on your machine that's isolated from all the other ones. This isolation leverages the kernel namespaces and C groups feature that have been in Linux for a very long time. I think they call it jails on BSD, if you're familiar with that. And Docker has worked to make these capabilities more approachable and easier to use. Really easier to use. So they can do a couple of things. You can have volumes attached to your containers. So when a container fires up, it's essentially reading an image. It's reading a copy of the code that it's going to run. And it can have its own variables, it can have its own data and so on. But when you close that Docker container down, it will essentially forget everything that it's learnt there. So if you're running like a database or something on there, you're going to lose all that data. So a volume is a way of storing stuff outside of the container so that when the container comes back up, you've still got that volume with all the data on it. You can have your own network infrastructure. It will allow you to have containers that can talk to each other, can have isolated containers that don't talk to the outside world. I don't know why you'd want to do that, maybe just testing. You can have containers that will talk to the outside world and have their own IP addresses as well. So you've got loads of flexibility from the sort of network perspective. And then the main thing is ports. So the way that we communicate outside and inside a container is through a port, almost like a porthole in the side of the ship. Ports are kind of universally understood in the networking and computer world. You just need to know what application ports you need open, and you can open them in your container. So it's easy to set up with Docker. So what I've done, I've created a GitHub repository. It's actually for the little machine you can see on the screen there. That's the clustered Pi. That was the original device that I set up, which had 12 Raspberry Pi Zeros in it, 2 Ws if you're interested, and each of them could form a cluster. So I created a whole bunch of what they call stacks in Docker, and you could essentially just fire up, say, run me 11 instances of Nginx, and it will just figure that out. And if any of the nodes get taken offline, they crash or anything like that, Docker will just redistribute those applications amongst the remaining nodes, and therefore you can scale things out very easily. So I put quite a lot of effort into creating an entire catalog of these compose files, as it calls it, Docker compose. And I've got one for Telegraph, one for Influx, and one for Grafana. I'll show you how quickly we can set those up too. So there's a stacks folder in clustered Pi. If you go into there, you'll find folders with names of all the different applications that are in there. And simply all you do is you go into that folder, you type docker compose up-d, and what that will do is bring up the container. It'll download any dependencies, any packages and so on, and you'll be up and running in minutes. So really, really good. So let's have a bit of a demo, shall we? Right, let me get over to my machine. I'm just going to put me on the screen a second while I bring up I'm going to bring up a terminal, so let me just do that there. Right, so this terminal I've got here, let me just arrange my screen a little bit better. Let's make it a bit wider. So this is a brand new, fresh install of Raspberry Pi OS. I have cloned the clustered Pi simply by doing git clone http, oops, too many P's there, and then github.com/Kevin McAleer/clustered Pi, like that. That will clone the repository, and you'll have all the files that we're going to be looking at today. And any new ones as well in the future that I develop, you can simply do git pull, and that will pull down any of the changes. So if I look in here, we have playbooks. Let's have a look in playbooks first of all. So I just do an ls. There is a Docker install. So if you do /docker install, that'll go ahead and it will install Docker for you. Sometimes you might have to run that twice just in case it doesn't have all the... If you have any problems in it, simply just have a look at that file. If you look inside Docker install, you'll just see there's a bunch of essentially installation scripty things. So it'll say if Docker is already installed, then do this. If not, it'll also add, so if you have a different user account, so obviously I have Kev as my main account, just change that to whatever you have there. If you've got Pi, just rename that to Pi. That will then just add the current user who we're using Docker to the Docker group, if you like. And then we've got a couple of other commands there, unmask and change mode. This just allows other applications to interface with Docker. This is the socket that it connects to. And then, yeah, to start it, it will just start up system control start Docker. So if I type in Docker, oops, with the correct letters there, we'll get all this kind of information. If I do Docker PS, we're not running any Docker containers at the moment. Right, so I'm going to go into my stacks folder. If I do an ls and show you what's in there, you can see we've got quite a few different containers. So the first thing I'm going to do is I'm going to fire up Telegraph. So let me go into Telegraph. Let's have a look what's in there. So I've got a little readme file. Let's have a look and see what's in there. Let's do a cat readme. Oops, it's all in capitals. And what I've said in there is if you want the host name of the machine to match the host name of the container, you just need to add this export host name, everything between those two ticks. You need to add that into your etc profile and log back out, log back in to make that take effect. And if you want to have to be able to read the containers, then you can do you basically just need to do this sudo chmod, either 666 or 777, and that'll give it all the right permissions. 666 is probably better because that doesn't give you write access to that, but it's not the most secure thing, but it enables everything to work nicely, which we need that if we want to be able to, for example, count how many containers are running on a machine. So what I'm going to do, if I just do that ls again, you can see that we've got this docker compose.yaml file. So let's have a look at that. Let's just do a cat just means like catalog .yaml. So you can see there we've got the word services. So this is a YAML file. This is the structure of a YAML file. We've got the service that's called Telegraph. The image, the thing that we're going to download from the web, I've already pulled this previously, so just to make the show a little bit quicker, I'll show you how to do that as well. And then we've got two volumes. So we've got one which will pull the telegraph.config file, and we've got one that will enable us to access the Docker socket from inside the container. It kind of punches a hole so it can reach into there, reach into the host OS and just look at some of the stats from the docker.sock. Restart always. This is a really cool command. This means when you restart your Raspberry Pi, it will also restart and bring up this container. So you've got a way of automatically starting things up without any kind of user interaction. And this is why I love this for building web servers and things, because you can just make them kind of self-healing and work. We've then got something called networks, and that monitoring net is down here, which it says driver bridge. So that's going to bridge it, allow our container to speak to other devices on the same local area network. It'll get its own IP address and that kind of thing, or possibly just use the same IP address as the host machine. Then the host name, that's the variable that will give us the this container will have the same host name. The host name is the name of the machine, like dev01. This one is simply called Raspberry Pi at the moment. So maybe we want to rename this one. If everything's just called Raspberry Pi, it'll be a bit confusing. So I tend to call things like dev7, things like that, for example. Then we've got the environment. That's a way of just saying grab the host name from the environment variable that's called hostname. And then this privilege true is needed because we're looking at the Docker socket, and we need kind of elevated permissions to do that. So a privilege kind of makes it run almost as like a root user. Again, not the most secure, but this is just grabbing some statistics. It can't do a lot else. So if we do docker compose up, I'll do up first of all and show you what happens. So it's saying there that the hostname variable isn't set. That's because I probably just need to edit that profile, etc. thing. And it's basically running the container now. But there you go. You can see there's some things come up there from the container. So it says it's starting Telegraph, loading the sensors, aggregators, processors, secret stores, and so on. And it's going to try and communicate now with the server. So I'm just going to do Control-C for a second, which is going to stop that container. If I do ls again, you can see there we've got this telegraph conf file. So let's have a look in that file as well. .conf. So this is where the configuration for Telegraph lives. So when I was playing around with the newer versions of Telegraph, you had to have some kind of password. So I was just using Telegraph and password, but the older version of Influx doesn't require any of that. You can simply just pass it the URL of the Influx server, give it the name of the database. It'll create that if it doesn't exist, which is pretty neat. The agent can be the host name, because we want it to show when we do our dashboard that this is the machine, Raspberry Pi, for example. One of the inputs we want is the Docker inputs, and I think that's everything else. They're all just comments. The other one at the top there, inputs.system, is a built-in one, which will give us all the disk, system, load, memory, and CPU usage as well as like percentages. So if I just do that again, if I just bring up and then do -D, this will mean just do it in detached mode. So it'll bring it up, and we can go back to our command line, and it's running in the background. So if we do docker ps, we can now see that Telegraph is running there in the background. Now, say we want to bring this down, we want to do some maintenance, we can do docker compose down, and that'll bring down that container. Because, for example, I want to fix that issue there with the host name being blank. So I think what I need to do is I need to, let's do sudo nano etc profile. And at the very bottom of there, yes, I'm missing a little command. So I'm going to flip over to the article that I've written there, and it tells me on here that I need to add a little line which is that one there, export. And what export does is it exports the variable that whatever the host name is, which is like Raspberry Pi on this example, and it'll export that into our environment variables so that we can pick that up in our Docker container. So I'm just going to grab that. I'm going to go back over here, just paste that in, do Control X, yes, to write the buffer. And now if I exit from here and then log back in, if I now do env and I scroll up, I should see that the host name is there, Raspberry Pi. So that's what it's going to be called when we run our dashboard in a second or two. So let's go back up into that clustered Pi stacks and Telegraph folder. Let's do docker compose up -d to bring that up, and it's not complaining anymore about that host name being wrong. So we've now added a new Telegraph node sending data to our Influx database. So I've already got an Influx database running, but if you wanted to set up an Influx database, you can simply go into the Influx database, do docker compose up -d, and it's going to grab any dependencies that it needs. It's going to pull them down. Thought I'd already done this, but clearly this is a specific version of Influx that it needs. And once it's pulled all of them down, you can see there's this nice little graphic just here that shows you for each of these different layers. It will grab all the dependencies it needs, and then when they complete, it will extract them all, and then it'll be ready to go. There you go. So pull complete. InfluxDB. It's doing that one as well. It's creating the container, and very quickly that'll be ready. That'll be actually running on this machine. And we can do the same with the Grafana. That's just as quick to bring that up as well. So we can do docker ps to see if everything's running okay. So yeah, that's been up 20 seconds. We do it again, you'll see it's been up 24 seconds. Let's now go back and go into Grafana. Again, we can look at that. Let's do docker compose up -d. It's complaining about the data directory not being set, so it's defaulting that to a blank string. That's fine, and that one's also pulling down everything there. So once we've done that, we've actually got all the components we need to start working on our dashboard. So what I'm going to do, I'm going to go over to the website in a second. I just need that to finish doing what it's doing, just so you can see it's reasonably quick to install, and because these containers are very, very lightweight, it doesn't take too long to download either. So that's now running. Now, but what we can also see, if we do docker ps again, we can also see what ports things are running on. So you can see Grafana is running. We can access it by going to that IP address and port number. So this is running on the local machine on port 3000. So if I was logged into this machine, I had a web browser, I could pull that up and I would see Grafana. So I'm going to do that just on another machine that I've got here. So let's go to the opening kind of screen. So this is what Grafana looks like when you first log in. You ask you to create an account, like an admin account, so just create a username and password. And then the first thing we want to do is create a new dashboard. So let's go and do that. Let's go to dashboards, and then let's create a new dashboard over here, new dashboard. So this is our new dashboard. We want to give it a name in a second when we save it, so we can click on the save thing, we can give it a name. Let's call this one live stream dashboard. Let's save that. Let's add a visualization, and it's going to tell us what data source do we want to use. So we need to set up some data sources before we can use a data source. So let's go over to here, go to our data sources. So let's click on that, and we can add a new data source. We can, honestly, there are so many different types of data source, it's frightening, but we simply want an Influx database one. And it'll ask us where is that located. So that Raspberry Pi that we've just set up, we can grab the IP address of that one. If I do IPA, let's scroll up to the top, and there's the IP address of this particular one. So 1.825, let me just grab that. Let's go back to over here. So if I paste that in, http / and then it's running on port 8086. And then if you go down here, you can say what's the database call. Let's call it Telegraph, and let's just save and test that. So it says data source is working, no measurements found, because we're actually not sending any measurements into that specific data source. But let's give that one a name. So we'll call this one test. I'm not actually going to use this one. I just wanted to show you how you connect up a new data source. Right, so now that we've done that, so we can go back to our new dashboard, so our live stream dashboard. We can go to that add visualization. We can select which data source we want. So InfluxDB1 test is the one that we just connected up. There's no measurements actually being sent there. So I've already created one that's called servers, which has all that data being sent from all the different Raspberry Pis on my network that I've included so far. So this area of the screen here where it says panel title, we can go over to the left here and we can look at the panel options, and we can start off this with a measurement. So let's just say disk, something like that. That's now got that title of disk. There's no data coming in, so we need to build a query to grab some data from those Telegraph sensors. So the first thing we do is select the measurement, click on that. We can go to disk. That's one of the types of measurement that comes from the system agent. The next one is where. So this is like the type of thing that we want to grab this from. So I'm going to click on this host thing because I want this to be from all the different hosts on our network. So I'm going to select the value there, and I'm going to type in $$ server name, and then $, and then /. Now that's really obscure. Like, what on earth is that? So let's get to that in a second. In fact, I'm going to get rid of that one. I'm going to just choose one of the servers first of all, and we'll come back to what on earth that thing is. I'm simply just going to find like Pi 400. That'll do. We're then going to select the type of kind of sub data within that disk. So we can look at the free space, we can look at the inodes used, we can look at the total, or use percentage. Use percentage I really like because we can graph that in some really nice ways. So we can see we've got some data on the screen now, and you can see also the time when these pieces of information, these measurements were taken. So we could call it quits. We could just say that's fine, let's apply that, and we've got like a new visualization on the screen, and we can resize this just by moving this around. Now that's great, but if I have to do that for every single host on my network, I'll be there forever. And if I want to have new hosts added to my network, I have to again go and recreate each of those, and that's not really very sort of workable. So what we're going to do is we're going to create a row. So what a row is a way of repeating the same set of data, same set of visualizations, but for different hosts. So the first thing we need to do, let's click on this little cog here, the dashboard settings. Let's go to variables, and let's create a new variable. Now, again, if this looks like it's getting really complicated, you can go to the how to set things up, and I'll go through all those different things on there. So don't worry, I've got you back on that one. Just seeing if there's anything on there. So we've got about creating variables on there as well somewhere. Creating a variable. There we go. So I'm simply just going to grab that query there. I'm going to go back over to my dashboard. So we're going to call this query server name. I'm going to scroll down to some of these options. So we're going to get the data from our servers, and the query that we actually want it to run, we want to say show tag values with the key of host. So host is the host name, and then down here we want to refresh this every time we change the time data range, the time change, and we also want this to be a multiple value. You can see there, here's some of the examples. We can see Raspberry Pi is now starting to come through, so we can apply that. We've now got this variable that's called server name. So let's close that. Let's go back up to our row, and if you hover over the row, you see this little cog appears when you hover over it. You can click on that, and you can say repeat for the variable name, which is the host. So let's update that. Let's make sure that this is actually under that row. If we collapse that, yes, that's now in there. And if we go back into here, we can click on these three little dots, we can click on edit, and then we can, instead of it being Pi 400, we can now use that variable name. So host tag, select the that thing we typed before, that's like a regex thing. It's a way of saying search for anything that has this $server name. So let me have a look and see if everything else is good with that. I'm going to click on apply. And at the moment we haven't got any data. So what's happened there is because over here there's a little drop down, and this allows us to select everything that we want to include on this repeating thing. So I'm going to grab all of my Raspberry Pi nodes. Let's just grab all of those. That'll do. And if we now change the time, let's just do like every 15 minutes. It's at the moment there's so many things on the screen. If I scroll, you can see it's got a new thing for each Raspberry Pi. We can't see them all, so in this example it makes sense to have like a really small block. Let's make it really, really small. But now the axis is kind of getting in the way of the actual data, as well as this little legend there, so we probably need to do a little bit more tidying up. So let's click on that. Let's scroll on the right hand side and have a look at some of these options. So let's get rid of the legend. So you can see now we've got rid of that disk in the bottom. We know it's disk. This is the disk visualization, and we don't actually need to have the axis that shows us the value there, because we can display this because it's a percentage. So we could even go over here, we can say the minimum value, the soft minimum is 0 and the soft maximum is 100. And let's see, somewhere on here there is an option for, I'm kind of covering this up with my face at the moment, with the axis. So I just want to make sure that's hidden there. So if I just go to hidden, we've now just got like the pure data. So if I just click on apply that, I change the time, that will basically refresh it. So we can now see we've got one for each of them, but they all say row title. It'd be really nice if that was the name of each of the hosts. So let's click on that again, and where we got row title, let's put that variable name in. So $server name, update that, and now we've got dev1, dev2, dev3, dev4, and so on. So at the moment that's not really showing us very much about the disk space usage. So what we can do again on there, we can change the type of visualization. So that's like a time series, like a line. It'd be nice if that was a gauge and we could see what that actually looks like. So now that that's a gauge, we've got a few more options on here. So I'm just going to hide my face for a second. Let's have a look and see what other options that we've got. So let's just open up value options, and let's scroll down a little bit. Right, so let's open up all these other options. Unit. So this is a percentage. If I type in percentage, miss percentage, there we go. We've got a nice little gauge that shows us things. We can also just confirm the minimum is 0, the maximum is 100. And we can now just apply that. Now that looks much better. Let's just refresh the time period again just to make it refresh all the others. And we can now see some real insights. Look at that dev04. That's using way loads of disk space. That's a terabyte. So it's using 60%. It's got 600 gigs of information there. What on earth is going on? Similar with the mail server. I know that happens to be quite a small SD card, so that might be an issue sooner or later. I like this idea that there's like a red line area where if there's any kind of problems, we can see that that's actually an issue there. So this is really coming into its own now. Let's add some extra information to this to make this really cool. So let's add another visualization. Instead of doing disk, let's change this now to be CPU. Let's change that to be the host tag again, where the value is that server name. We're going to change the field value to be, let's have a see what looks useful on here. So we've got usage guest nice, idle, system. So maybe we could have system and user. So one of the nice things with this is you can have two queries on the same visualization. So we can have another, it's now got query number 2. So you can see this query A and this query B. So query B, we can select the same thing. We can go for CPU, where the host name is the server name. And then we can pick a different field on here. So we could say, let's go, we went for, was it system? Let's go for user on this one. So we've got two little things. Now those dots would be really nice if they were kind of joined together, and those dots represent a measurement in time. So what we'd like to see is kind of join the dots. So let's scroll down on the right hand side again. I'm just going to hide me again. And let's see if there is a way of joining these lines up. I'm pretty sure there is. So connect null values. Let's say always. We've now got two little lines, which means we can see that data a lot easier. So we could leave, if we wanted to, those two things at the bottom there, but let's give our panel title a name as well. So this one is CPU usage. CPU usage. And apply that. Again, let's shrink this one down a little bit. Let's make it about the same height as the other ones, and then let's drag that into one of the rows like that. Again, if we just change that, it's now showing that for all of the different servers. So that's interesting. Devo 4 is not doing very much, neither is the mail server, but some of the other ones are looking a little bit busier there. Now they are all different ranges. Look, that's 2 to 4, that's 0 to 2. So it's better to have like a percentage, I think, for these things, because then it's standardized across the piece. Let's carry on then. I'm going to save that changes, so save the dashboard, save it. You can actually have all these changes saved. It's just source code behind the scenes, so we can actually save this out to somewhere like GitHub, so we can restore all this hard work in the future if anything happens, or share it with other people as well. So let's add in another measurement. So this time let's go for, did we do disk? Let's do that Docker one. So because I'm running Docker, I'm just going to call that one Docker. I want to know how many containers are running on each of the different machines. So let's do that where the engine host, this is different for this because it's a Docker agent. It's the same thing, it means the host name. So let's choose that server name variable again. And then for the field, let's choose n containers. That's the number of containers that are running. Now let's change the type of visualization. I'm going to use the stat this time, so we get a nice big number. Now we can't be running half a container. What's happening there is that this is a mean function. It's taking an average over time, and that doesn't really make sense in this scenario. But let's just go with it and see what happens. So let's apply that. Let's shrink that one down, and then let's move that one over to here. Let's stretch that out a little bit more, and then let's update the time again. That's better. So we can now see the actual number of data. So we can see some of these nodes haven't even got Docker installed, so they're not bringing any data. That's fine. Yeah, we can see there how many Docker containers they're running. And this little graph, it's got the current highest value, like the latest value. And it also shows you over time. So not sure if I brought any extra containers up in the past 30 minutes on there. Maybe if I change that to like the last 3 hours. Look how quick it is. There you go. You can see on that Devo 2, I've just been rebuilding that this afternoon. So 3 hours ago it had no containers, and now it's got 4. So you can see that, and that corresponds to a bit of a bump in the CPU usage as well. Okay, let's carry on. So we want also to have, let me bring my notes up on my other screen. We want to have, so we've done host CPU uptime. Let's add that one. I think that's quite a useful one to have. So visualization, I think this is also on the system. If I go down to system, where the host tag is server name, the field value is uptime. So let's grab that. And again, I don't want to see the uptime going up as a graph. That doesn't make too much sense, but it makes sense as a stat. So let's grab that there. I'm just going to hide me again. And if we look on the left hand side, let's just call that one uptime. So what is this 115,425? Hazard a guess of what that might actually be. So if we scroll down over here on the right hand side until we get to the units, and let's change this to seconds. So this is time, seconds. And this is what's cool about Grafana. It knows that seconds, you don't want to see it in like seconds, you probably want to see it in days. So let's change that to 2 days. We can do that. So let's apply that. Let's shrink that one up. Let's drag that over to our row. Let's just make it square as the same as the rest of them. Let's change our time again to update everything else. And we can see that quite a few of these have been up one nearly 2 days. This one has only been up just shy of 4 hours because I rebuilt that one because it failed after that reboot, after that power outage. Okay, let's now add, I'm going to go and add some extra ones in just to show sometimes gauges are better, sometimes graphs are better. So if you want to see the data changing over time, the graphs are better for that. If you just want to get a feel for where it is now, then the gauges are probably better. So let's add in another visualization. So this time let's go for memory usage. So that's going to be, oops, what did I type wrong there? So measurement is going to be, as I said, memory usage into memory, where the host, sorry, is that variable. And then the field, we're going to choose, again, we want something that's like a percentage. That's probably the best thing. So used percentage, that sounds good to me. Let's change that to be a gauge. And let's just give that a title of CPU usage. Maybe just CPU, because that's nice and short. So let's grab that, shorten that a bit more, move that over to our row. Let's change the time period again to update everything else. So you can see there our dev2 machine is really sort of hammering it now. We haven't set them as a percentage, so that's showing 30 there, that's showing 7 there. So we need to go back in and edit the type of data that's coming in. So let's scroll down over here. So the unit is going to be a percentage. So you can see just behind me there it says MISC percent 0 to 100. Let's do that. And we can just, for clarity, just say the minimum value is 0 and the maximum is 100. Let's do that. Okay, and then let's apply. Let's update. And now that makes much more sense. So yes, we can see Dev01 is using 30% of its CPU. The mail server is using nearly 50%. I need to look into that. That sounds a bit unusual. What else have we got? Node 3, that's using quite a bit, and so on. So one of these disk spaces was quite, yeah, that node number 4 is using quite a bit, and I think Dev04 was also using quite a bit. Yeah, look at that, 62%. I'm pretty sure that's because it's using too much, it's got too much in its cache, and we need to purge the cache from Docker. So every time you download a Docker container, it caches it, and we essentially want to prune that. So let's just exit from this machine. Let's go into 2.4, and then let's do a docker system prune-f, and that's basically going to get rid of all the containers and things that are not currently being used and we're just there. So we've got rid of 25 gigs worth of stuff. So if we now go back to over here, and let's change the data range to be the last 5 minutes, and let's see on here if we get to see a change in that value. I think it sends the data every sort of 30 seconds or so. That's something that you can actually change. I think I did name that one wrong. Somebody's just said there. So let me just go back in. Oops. Edit that one. And so yes, it's actually memory, not CPU. Thank you for that, Steve. Let's change that. Memory. So CPU, let's actually add that one in. We've got a CPU usage over there, and that's kind of showing it over time, but it'd be nice to have another graph that shows it in that kind of gauge way. So let's go for CPU. Let's call it CPU so I don't forget. Let's say where the host tag is the variable, and the thing is, let's go for user. That'll show us kind of what's going on there. And I'm going to change the type to be a gauge, and because it's a percentage, let's find the type, the unit, type in percentage MISC, and to see that there, percentage MISC, minimum is 0, maximum is 100, and let's apply that, shrink that down, and then let's just add that to our row. That's another one. There we go. Make that the same, change our time to make it filter down, and we can see there everything's sort of doing okay user-wise, user application-wise, so there's nothing too taxing going on there, which is good to see. So you can see we can very quickly build up quite complicated looking dashboards, and this is just one dashboard. And if we want to filter that just by you know, 1 or 2, or maybe just the 4 servers that are running Kev's robots, for example, I can filter out all those, and I can just see the 4 machines that I'm interested in there, for example. And we can even go ahead and even shrink these down a bit further to make our rows a little bit tighter together. Just need to update the time. There we go. And we can almost see them on one page now. We could probably go ahead and shrink them down even further to make them fit on a single web page. Let's just change that to like the last 3 hours. There we go. Look, we can almost see them all at the same time. And we can see therefore that Dev04 has been pretty busy. And let's go to the last 5 minutes now that we changed that disk space and see if that's changed. It's not changed on there yet, but we could add in an extra visualization, or simply change that one. We can just go in and you have to go to the one at the very top of the row to edit it, and we could change that. Instead of being gauge, we could just change it back to a time series, apply that, and then filter that down. So let's go to the last 15 minutes, for example. Waiting for that to update everything, and you get the idea. So this is actually running on, I think, Dev04. Yeah, so 192.168.2.4. So I'm not sure why it's decided to go a little bit slow there. Maybe we'll just go back to 5 minutes there, and we can also just click on the save and save any changes there as well. And I think the Influx database, that's also running on Dev04 as well. Cool. So I'm just going to jump back out here. I'm going to look through my notes to make sure I covered off everything I wanted to make sure we covered off as well. I think so. I think we've got everything covered off there. So yes, if you want to get yourself one of these amazing Robot Maker hats with the Robot Maker at a bit of a jaunty angle, then you can go over to the kevsrobots.com/merch shop and get yourself one of those. Maybe get somebody one for Christmas. It's a nice gift. You can also get the Kev's Robots mugs and the branded notepads as well as the hoodies there as well. Cool. So we also have a Discord service. I think the Discord thing might be broken at the moment, the thing that sends you the links. If you want to get a Discord link, let me know in the comments and I will pick that up. I'm pretty responsive to when people make comments on YouTube. I can send you that. I can basically just post a reply to a link on that one to get that working. I'll look into why that's broken, but yeah, I know that I think James tried to get a connection the other week and it wouldn't send him the email. When I looked into it, something was broken behind the scenes. I use MailChimp to do all that kind of automation, but we do have a Discord server. You can also, if you're on an existing server, you can find the Kev's Robots one, and I think you can request access that way as well, I believe. You can also follow me online. I'm on all of the different social medias. So if you go to Kevin McAleer at threads.net, you'll find me on there. I think that's the primary place I kind of hang out. I'm also on TikTok, Kevin McAleer 6. I'm on Instagram at Kevin McAleer. I'm also on X as well. I know a lot of people are going off X now. I'm on there for now. I'm just going to keep it active. I'm also on Mastodon, Kezmac at mastodon.social. And I'm also on B-Sky as well. I think I was one of the first users on there because everybody seems to be joining that now as well. So yeah, kezmac.bsky.social on there as well. And if you want to join me and support the channel, you can do that in a number of different ways. If you go to kezrobots.com/coffee, that's probably the easiest way you can physically buy a coffee to me. And I'm a big coffee drinker, a bit like Network Chuck. I do like to drink my coffee, so you can do that there. You can also do a buy me a coffee membership, and that essentially buys a coffee every month. Or if you want to do it the YouTube channel way, you can do that by clicking on the YouTube join button as well. And I want to give a shout out to our supporters as well. So we have a number of different supporters on here. So on the left hand side, I have to kind of mirror this. I'm actually pointing to my right here. So we've had 3 people buy me coffees in the past month. We've got somebody wanting to remain anonymous. We've got Adam. Thanks, Adam. We've got John as well. Thank you, John. And then the usual members, people who are buying a coffee every month. So we've got Andy Brooker, we've got Shemi, we've got Jeff Johnson, and we've got Steve Phillips. Hey Steve, I know you're on today as well as Jeff. We've also got Dean Corty, Marlene Brent. Hi Marlene. And we also have Tom as well. Thank you for that. And then on the YouTube membership side, we've got Dale, who has 2 accounts. We've got Hybrid Robotics with an X and Hybrid Robotics with a C. We've got Ford, we've got Bello, we've got Orksrad39, we've got Littleback, we've got Paul, we have Johnny. Hey Johnny, I know you're on the channel today as well. We've got Handsome Cheerlights, we've got Prem, Kumar, we have Stephen Cross, we've got John Paul Jolly, Alistair Ware, Cassie, Tinkering Rocks, Johnny, and we have Tom as well. So thank you everybody for supporting the channel. It means so much to me. It means I can go and get all the bits and pieces to keep this channel interesting. Cool, so I think if I go back to my notes there, yes, this is the part in the video I'll say YouTube will be recommending over here a video for you to watch, so I strongly suggest you check that one out. It'll be something very interesting, probably related to some of your interests from the back catalogue of the 300 plus videos that I have on the channel, so definitely check them out. Let me know, like I said in the comments, how many Raspberry Pis you have, and I'll be looking at that in a second on people who've responded on the live chat as well. So at this point in the video, if you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time.